All right, we are going to be looking at part 3 of the Solving Multi-Step Equations notes. We're going to look in this section at special cases. What happens when we are solving an equation and all of our x's cancel out? Like, what do we do there when we're only left with regular numbers, only left with constants? And then we're also going to look at some word problems and how we set up the equations for those. All right, so starting off, we're going to look at example 8. So in example 8, we can see that on the left-hand side, we've got some parentheses, so we need to distribute. So we're going to do like we did in part 2. We're going to distribute. And so that's going to leave me with 5x plus 35 equals 35 plus 5x. All right, now, if you're looking at this, you should see these are the same exact things on each side. They're just reversed, right? Just in a different order. I've got a positive 5x on each side and a positive 35 on each side. So that means that what's going to happen is when I go to move my x to get it over to the left, it's actually going to cancel out on both sides because I get 0x on both sides. And so all that's going to leave me with is 35 equals 35, all right? The x's have canceled. So we're going to write ourselves a note. X canceled out on both sides. Okay, so when that happens, we need to ask ourselves if what's left is true or false. Okay, so 35 does equal 35. That is true. Okay, so when that is true for our solution, we're going to say all real numbers. Okay, that's our solution. They may use a symbol for all real numbers. The symbol for all real numbers is like a fancy R with an extra leg. Sometimes it's really like curly. But what this means is it means I could use any number for my x and this equation would be true. This equation would have the same value on each side of the equal sign, no matter if I used x equals 100 or if I used x equals a billion. Okay, so that's what that means right there. All right, let's look at example 9. So on an example 9, I can see on the right-hand side, I need to distribute this negative 3. So the left-hand side is still going to be 3x minus 6. The right-hand side is going to be negative 3 plus 3x. So once again, my sides are not exactly the same this time, but I can see my x's are the same. I've got a positive 3x on both sides. So when I go to move my x, they're still going to cancel out on each side. And this time it leaves me with negative 6 equals negative 3. Okay, so once again, x canceled out on both sides. All right, so I've got to ask myself if this is true or false. Negative 6 does not equal negative 3, so this is false. And so when it's false, my solution is going to be no solution. All right, there is no value of x that would work with this problem. All right, it doesn't matter what I put in there. Nothing is ever going to work. This is kind of like a broken equation. It'll never be equal. And so we say no solution. You may see the symbol for no solution. It's like a 0 with a line through it. That's what that means. All right, so once again, I really want to emphasize that for both of these special cases, your x canceled out completely. It no longer existed. We had 0x on both sides of the equation. That's the only time you should come up with these two answers. If you get, let's see, I know we had one. If you get x equals 0, right, the x didn't cancel out in this problem, right? We still had it. So x equaled 0. That's a different thing. That is a solution. X does equal 0 there. I am not going to say no solution on that one or all real numbers. We only say all real numbers are no solution if the x is canceled out on both sides. And the only thing you're left with is constants. It's regular numbers. All right. So now looking at word problems. Okay. With the word problems, the key to them is to take it a piece at a time and to really just take a second to write down what you know. All right, write down what you're getting from the problem. If you take it slow, instead of trying to work with the whole thing all at once, you'll be able to set up an equation that you can then solve. All right, some of these word problems you can solve simply without an equation, but there are going to be times when you can't. So it's better to practice how to do it correctly. So example 10, we're going to start with this first sentence right here. Okay, so from this first sentence, it says the length of a rectangle is twice its width. So I know a couple of things. I know that I'm dealing with a rectangle. Okay, and I know a rectangle has a length and a width, right? And then it says the length is twice its width. So what they just told me is they told me that the length is equal to 2 times its width, twice its width. All right, so right now, this is what I know from just that first sentence. So now we're going to look at the second sentence. The second sentence says the perimeter of the rectangle is 126 feet. All right, so let's think about perimeter and what we know about perimeter. So one thing is they said the perimeter is 126. That means it equals 126. Is like your equal word. Okay, so we know that P is equal to 126. We also know how we find perimeter of a rectangle. Okay, perimeter of a rectangle is when we add all 4 sides together. So notice you've got 2 sides that are length and 2 sides that are width. So I need 2 lengths plus 2 widths. Or you can just list it all out. We've got to add a length plus another length plus a width plus a width. Either way works, all right? To me, the first one's shorter and simpler, so that's the one I go with, but you could use the other one. Either way, this is how we find perimeter. All right, and then we've got our question statement. All right, it says, what are the dimensions of the rectangle? So when they say dimensions, they're asking me, what does length equal and what does width equal? All right, that's what we are solving for here. All right, so that's how we're going to know we're done, when we find the length and the width. Okay, so let's start piecing together what we know. So we've got this little formula that we came up with for the perimeter right here. All right, we know some things that we can plug in on that formula. We said the perimeter is 126, so instead of a P, I can write a 126. I also know that L, right here, we said L is equal to 2W. So I'm going to replace that L. So I'm going to write the 2 that I had, and then instead of L, in a set of parentheses, I'm going to write 2W, because we said L equals 2W. And then I've got another plus 2W. Now, I don't know anything about the width, all right? It's just W, it's just floating there. So I'm just going to bring that down, plus 2W. So now I've got an equation that only has one type of variable. This is something that I can solve, and it will tell me what W equals, all right? So first step, we are going to multiply right here. All right, so what I have is 126 equals 4W plus 2W. Okay, so now these two are like terms, 4W plus 2W, so I can add those together. So 126 equals 6W. And then remember that last step, once I've got my variable on one side, my number on the other side, is to divide. So I'm dividing by 6, and 126 divided by 6 is 21 equals W. It doesn't matter that my W is on the right-hand side. It's the same thing. I can just easily flip it around and say W equals 21. So I have found my first answer. I have found that my width is 21 feet, all right? Because we're talking feet for this problem. I wrote that too big. Feet. Now I need to find the length. So going back, we said the length is equal to twice the width. So if the length is equal to 2 times W, that means the length is equal to 2 times 21. So my length is 42. So my length, I'm going to put 42 feet. All right. And then I have solved the problem. Those are my answers. Those are the dimensions. I could test them out to see if they're true by finding my perimeter using 42 and 21 as my length and my width and making sure it equals 126. All right, last one here. It says 1 month, Ruby worked 6 hours more than Isaac, and Svetlana worked 4 times as many hours as Ruby. All right, so we're going to start with this first sentence here. And we're going to kind of piece together what we know. I can see that we're talking about 3 different people. All right, we hear about Ruby, we hear about Isaac, and we hear about Svetlana. Okay, very exotic there. All right, and it's talking about how much each of these people have worked. So first it says that Ruby worked 6 hours more than Isaac. All right, so I know Ruby is going to be however much Isaac is plus 6. All right, I'm just going to use an I for Isaac. And then it says, so we just did this part. And then it says, and Svetlana worked 4 times as many hours as Ruby. Okay, so for Svetlana, we know it is 4 times whatever Ruby is. Well, we said Ruby was Isaac plus 6. So I'm just going to write Isaac plus 6 there. Right, that's Svetlana. Now, we don't know anything about Isaac here. All right, Isaac is just Isaac. He worked however many hours he did. Okay, so if you wanted to use an X instead of an I, you could. I'm just going to leave it as an I, and we're going to roll with it. I'm letting I stand for the number of hours that Isaac worked. Okay, that's what our I is representing here. Now let's look at the next sentence. The next sentence says, together, they worked 126 hours. So that's their total. So if they all work this together, that means if I add Ruby plus Isaac plus Svetlana, it will equal 126. And then the last sentence says, find the number of hours each person worked. And so we will know we're done when we know how many hours Ruby worked, how many hours Isaac worked, and how many hours Svetlana worked. Okay, so let's see what we can plug into our equation that we've kind of started here. So for R, we said that Ruby was Isaac plus 6. So instead of an R, I'm going to put I plus 6. And then we've got plus Isaac. We don't know anything about Isaac. He's just Isaac. And then we've got Svetlana. We said Svetlana was 4 times I plus 6. So I'm going to write that. Plus 4 times I plus 6. And then we equal 126. So now I've got an equation I can actually work with. I've only got one type of variable. That means I can solve and figure out how many hours Isaac worked, and then use that to find out Svetlana and Ruby. So working through this, I need to distribute this positive 4 first. And so if I distribute, I'm bringing everything else down just to take this a step at a time. This will give me plus 4i plus 24 equals 126. Then combining like terms, I see that I have 1i plus 1i plus 4i. So 1 plus 1 is 2, 2 plus 4 is 6. So that's 6i. Then I also have a positive 6 and a positive 24 on that left side. So that gives me a positive 30. And then I still equal 126. So now solving for I, I'm going to subtract 30 from each side. And that leaves me with 6i equals 96. And then my final step is to divide by 6. And so I get I equals 16. All right, so we figured out Isaac. Isaac has worked for 16 hours. Now we need to figure out Ruby and Svetlana. So for Ruby, it said she worked 6 more hours than Isaac. So that means she worked 22 hours. Okay. And then Svetlana worked 4 times as many as Ruby. So we got to do 4 times 22. So Svetlana has worked 88 hours. So just by figuring out how many hours Isaac worked, we were able to solve for all of the others easily. You once again can test that by adding all three together and making sure it equals a total of 126.